Now in this video lecture, we will discuss the solution of the cubic equation by using the Carden methods. Now, step by step, we can solve the cubic equation here. So directly we come to the example. We have considered this example. Solve cubic equation x cube minus 18x plus uh, minus 35 it is equal to 0. Say it is your equation number 1. Now, this equation is incomplete. Why it is incomplete? Because the coefficient of x square is absent in this example. So one point is important here. You can mention that the coefficient of x square is equal to 0 in equation number 1. This is very important part. So once the coefficient of x cube or x square, coefficient of x square is missing, then how we can apply the Carden's method? Demonstrate by using this example. So step number 1, you take x, it is equal to u plus v. You can take x is equal to u plus v. So you can take x is equal to u plus v. Then you get the x cube, it is equal to u plus v whole cube. That is equal to u cube plus v cube plus 3 times uv u plus v, or it can be written as u cube plus v cube plus 3 times uv into x. That is equal to your x cube. Now transfer this part, x cube minus 3uv x minus u cube plus v cube is equal to 0. Say it is your equation number 2. So equation number 1 and equation number 2 is a cubic equation. You observe that the equation 1 and equation 2 both are cubic equation. So we simplify, or we can write down the minus 3uv is equal to minus 18. That is uv becomes to be 6 and u cube v cube is equal to your 35. I think this line is clear, very simple. We compare the coefficient of x cube, x and constant term from the equation number 1 and 2. Then we get this term here, very easy. Now, we find out the u cube and v cube. That is, it is equal to 216. That is, it is your, if we find out u cube into v cube is equal to 216. So, if you are focused on these two lines, so it becomes your sum of u cube and v cube, and it becomes to be product of u cube and v cube. So we form a quadratic equation. This is our step 2. We form an quadratic equation whose roots are u cube and v cube. So by using the concept of quadratic equation, we get t is a variable, minus sum of roots into t plus the product of roots into is equal to 0. So we get here t cube minus the sum of root is 35 t plus product of root is 260. Say it is your equation number 3. So definitely we get the two roots, the t1 and t2, and t1 represent here u cube and t2 represent here v cube. Okay, because it is a roots whose roots are here already mentioned that the roots are u cube and v cube here. Now we simplify this part. This is your t square minus 27t minus 8t plus 216, it is equal to 0. You can take t is common, t minus 27, minus 8 is common, t minus 27, it is equal to 0. So we get here t is equal to 8, so it is your t1, and t2 it is equal to 27. But t1 it is equal to u cube, and this u cube is equal to 8. Okay, so this t1 or u cube is equal to 2 to the power sorry 8 to the power 1 by 3. Sorry, it is u is equal to 8 to the power 1 by 3. So u becomes 2 to the power 2. But here 1 is silent. That is, you can write down this is 8 into 1 to the power 1 by 3. This is very important. It is very important. So 8 to the power 1 by 3 becomes 2, 1 to the power 1 by 3. Okay. The question is how to simplify x is equal to 1 to the power 3. Or you can take any another variable y it is equal to 1 to the power 1 by 3. Remember that it is the third root of unity. So this 1 can be written as 1 plus 0 iota to the power 1 by 3. That is where we use the de Moivre's theorem concept to simplify our 1 to the power 3. Now for this, we can put 1 it is equal to r cos theta and 0 it is equal to r sin theta. Okay, so r becomes to be 1 and theta becomes to be 0 degree because cos 0 is 1. So y can be written as r to the power 1 by 3, then cos theta plus I sin theta to the power 1 by 3. Because the r is 1, therefore this is because it is r is 1, therefore y can be written as the cos theta plus I sin theta to the power 1 by 3. Is it clear? I think this line is very simple. There is no complication. You can substitute in this way. Now, what is our de Moivre's theorem? The de Moivre's theorem says that if we have the cos theta plus I sin theta to the power 1 by n, then it is equal to cos theta by n plus I sin theta by n. This is your de Moivre's law. in particular case of De Morgan's law. It is not a complete De Morgan's law, but it is a particular case of the De Morgan's law. And we know that cos theta, it is equal to cos of 2n pi plus theta, because exactly after the n round we get the exact same value. Similarly, sine of 2n pi theta, it is equal to sine theta. So here we can write down our y is equal to cos 2n pi plus theta. Theta is your 0 plus I sine 2n pi plus theta. Again it is equal to 0. Rest to the power 1 by 3. Now we apply the De Morgan's law. It becomes to be cos 2n pi upon theta 3, because theta is 0. I sine 2n pi by 3, and the value of n becomes 0, 1 and 2. Why we are not taking the n it is equal to 3, 4, 5 and so on? Because if we are taking n it is equal to 3, then we get exactly the same value as n is equal to 0. Similarly, if we are taking n it is equal to 4, then exactly the same value as n is equal to 1 and so on. Now we put n it is equal to 0 here. Then we get first root y1. That y1 is cos 0. Cos 0 is 1. If we put n it is equal to 1, then we get 2 pi by 3 plus I sine 2 pi by 3. Okay. The cos 2 pi by 3 can be written as your 120 degree. Okay. Because 360 multiplied by 270, 270 is 150, pi minus, this can be written as your cos 180 minus pi by 3, that is equal to 2 pi by 3 plus I sine pi minus 2 pi by 3, pi by 3. Okay, but cos 180 minus theta is minus cos theta. So it is your minus pi by 3, sine 180 minus theta is your sine pi by 3. The cos pi by 3 is minus half plus minus plus I root 3 by 2. Similarly, if you take n it is equal to, say it is your omega. If you take n it is equal to 2, then we get its conjugate, that is your omega square. What is your conjugate of this problem? Minus half minus I root 3 by 2. Because we know that if the roots occurs in the complex number, then they are occurs in the conjugate pair form. The one root is positive, then another is negative, because this is your conjugate. Okay, so it is your conjugate form. So what is the value? Value y it is equal to 1 to the power 1 by 3 provides the three roots. Y1 it is equal to 1, y2 it is equal to minus half plus I times root 3 by 2. Y3 provide minus half minus I root 3 by 2. It can be written as omega. It can be written as omega square. And we know that here, here we know that u it is equal to 2 into 1 to the power 3, means 2y. Then we get the three roots, three different roots. So u1 becomes to be 2, u2 becomes to be 2 into omega, because 2 into y, and u3 becomes to be 2 into omega square. This is the roots of our u1, u2, u3. Similarly, what is the connection between the v? The T2 it is equal to 27, that is equal to V cube is equal to 27, that is V is equal to 3 into 1 to the power 1 by 3, again 1 to the power 1 by 3 is attached here, So V1 it is equal to 3, V2 it is equal to 3 into omega square, omega, and V3 is equal to 3 omega square. Okay. So by this technique, we can find out the roots. But you know that what is our t? Our t is what is our x? X is u plus v. So x1 it is equal to u1 plus v1. So u1 is 2 plus 3. Then we get 5. X2 it is equal to 2 omega plus 3 omega. That is we get the 5 omega. And x3 it is equal to 2 omega square plus 3 omega square. Then we get 5 omega square. So the solution of this cubic equation is 5, 5 omega square, 5 omega and 5 omega square. Or you can write down in this way 5, 1 omega and omega square. So I hope that you can understand the solution of the cubic equation by the Carden's method. Thank you very much.